Hi folks, and welcome to another edition of Zog Science. Today we're going to be looking at how do we make good graphs, and then how do we draw a line of best fit, and then finally how do we come up with a science equation based on our graph. So if we take a look over here, this is going to be the data that we're going to be working with. We've got our noodles, remember this is from our spaghetti lab, and then we've got our number of washers. So first thing we want to do when we make a graph is we got to make sure that we know and label our axes, right? We've got our x-axis down here and we've got our y-axis right here. Our number of noodles, right, that is our independent variable in this experiment. That is what we changed. We changed the number of noodles in our spaghetti bridge. Our dependent variable, that is our number of washers. So our independent variable is always going to go on the x-axis. Our dependent variable is always going to go on the y-axis. So we're going to put the number of noodles down here, and then we're going to put the number of washers on the y-axis. Noodles on the x because it's the independent variable, washers on the y-axis because it's the dependent variable. Next thing we need to do is we need to come up with the scale for our axes. We want to start with 0 over here. That's our origin. And then we've got 5, right? That's our biggest number of noodles. So we need to make sure that we have a consistent scale that goes up by a similar amount. So if we go 1, 2, 3, 4, 5, that's going to really spread out our data for us well. So we're going to go every 2 boxes is going to be worth 1. So there's 1, 2, 3, 4, 5. Okay. Now for our number of washers, that may be a little bit trickier, right? We're going up to 76. So in this case, what we're going to do is we're going to go by tens. So here's 10, 20, 30, 40, 50, 60, 70, 80. Now when you're doing your scales, you want to make sure that each box, right, on your graph is worth the same amount. All right, that's very important. It's going to be very important, especially once we start getting into drawing our lines of best fit. Okay, you want to make sure that it is the same amount for each one, and it's okay if your x-axis is different from your y-axis. All right, that's acceptable. The best way to probably go about doing this is just some trial and error. Just pick a scale that you want, and then try it out. If it fits, that's good. If not, then you probably have to restart it again. The next thing we're going to do is we're going to actually graph our points. All right. So our first point is 1, 16. So we'll go to 1, and then 16 is a little bit more than 15, right? Which would be halfway between 10 and 20. So it's just a little bit above that. Then we've got 2, 29, and then 3, 48, should be just a little bit less than 50, and then 4, 61, and then finally 5 and 76. All right. Now we've got our data points. The last thing we need to do in order to make sure that we've got a good graph is we've got to make sure we've got a title. Okay, so we've got our title. The next thing we're going to do is we're going to look at our data. Right, we're just going to take a look, and you'll notice that our data is pretty straight. Right, it's a fairly straight, but it's not exactly a straight line. And so what we want to do now is we want to draw a line of best fit. And in order to draw a line of best fit, we're going to need a ruler or a straight edge, and we're going to lay this ruler down so that it is following our data. All right, and it's not necessarily going to be exactly on the points, all right, and that's okay. We don't care about that. We just want to be following the data. Now, sometimes when you start your line of best fit, you want to think about starting it at 0, because let's think about this. If we have 0 noodles in our bridge, are we going to be able to hold anything in our washers? No, right? So in this case, let's go ahead and make sure we start that at 0, and then we want this line to kind of go through our data. All right, and mine is a little short, so I'm going to have to extend it up here a little bit. All right, there we go. So there's my line of best fit, okay? So we've got our line of best fit drawn. The final thing we need to do, or the next step we need to do, is we need to come up with our science equation, all right? And our science equation is a way to describe and talk about this line, and it's a way for us to talk about the relationship between the number of noodles and the number of washers. When we draw a line of best fit, all right, we're going to use that to come up with our science equation. We're not going to worry about the points that we have already drawn on the graph. We're not worried about those now. Now we're just going to look at our line of best fit. So the first thing we need to do is that we need to figure out the slope of our line, okay? And when we figure out the slope of the line, we need to pick 2 points. And those 2 points should be points that are on corners of the graph. And the reason why I want you to pick those is that it's going to be easier in order to figure out what the x and y coordinates are for each of those points. So this is a spot that's right on a corner. And if we take a look, we've got another spot right here that's really close to a corner. It's okay if it's a little bit off, but as long as it's really, really close, we're going to get a good answer. All right? So in order to figure out slope, right, slope is equal to rise over run. All right? And rise, if you'll recall, is where you go up. That's the y. And then the run is your x. All right, so here's the rise, and here is the run. So our rise here, all right, let's count this out. We're starting off at 30. Remember, each of our boxes is worth 10. So this is 10, 20, 30, 40. This is 40. And remember, don't forget about your units, that's 40 washers. Okay, so our rise is 40 washers. Our run, now remember that we skipped a box to go up by 1. So what that means is that each box is really worth 0.5, right? 2, 2.5, 3. So we're starting at 2. So let's go here, and we're going to go over. So that's half, 1, 1.5, 2, 2.5. So our run here is 2.5. And remember, our unit here is noodles. Okay? So recall, slope is rise over run. So now we've got to take our rise and put it over our run. So that's 40 washers. I'm just going to abbreviate that W, divided by 2.5 noodles. And then we need to take that and we need to divide it. All right? So that's 40 divided by 2.5 is going to give us 16 washers over 1 noodle. This is our slope. All right? 16 washers divided by 1 noodle. What that means is that every noodle, for each noodle that you have in your bridge, you can hold 16 washers. All right? Pretty cool. So this is describing to us the relationship between washers and noodles. The final step in this process is we need to do our science equation. And in order to do our science equation, we need to start with the equation for our line. And the general equation for a line is y is equal to mx plus b. All right, that's the general equation for a line. The y is your y-intercept. What we're going to do now in order to make our science equation is we're going to take our general equation, we're going to make it specific. So the y, that's our number of noodles, is equal to m. M is our slope. Our slope here is 16 washers per 1 noodle times x, right? mx, m times x. The x is our x-axis. Oh, I got this confused. This should be the number of washers. Right, our y-axis. Hopefully you caught that. Number of washers. Our x-axis, that's our number of noodles. Okay? And then plus b. B is our y-intercept. Well, recall that we had our y-intercept at 0 because we decided to start at 0. So that's going to be 0, and our y, again, is washers. Okay? And this now, here is our science equation. You can see that our science equation allows us to now fully describe the relationship between washers and noodles, and we can also use this to make predictions. Because if I tell you how many noodles a bridge is made out of, you can plug that number in, and then we can determine how many washers that bridge would hold. Or I could tell you that a bridge holds a certain number of washers, and then you can use that to figure out the number of noodles that the bridge is made out of. Okay? So if you have any questions, feel free to come in and ask me. Otherwise, thanks for watching, and I'll see you next time.